Welcome to the session number 11 from the playlist of JEE Advanced Part 2. The topic for the today's session is electric flux, and based on this topic I have selected one question which was asked in the advanced paper in the year 2017. So the question here is, the point charge Q is just placed outside an imaginary hemispherical surface of radius r as shown in this figure. So this is the figure which was provided along with this question. So this is a charge Q which is just placed outside this imaginary hemispherical surface at this point, say P. So we have to find the electric flux which is passing through the curved surface. This is the first part of the question, and the second part is we have to find the total flux which is passing through this curved surface and the flat surface. The flat surface here is A, B, C, D, and the curved surface here is A, P, C. So in this question, this charge Q which is placed just outside this imaginary hemispherical surface will generate the flux which will be given by Q upon epsilon naught, and this flux will be passing through this curved surface and will be directed inwards. That is, the flux will be directed like this. Now since we know that the flux which is entering into a surface is taken as negative, and the flux which is leaving a surface is taken as positive. So in this case, the flux which will be passing through this curved surface, that is AQC, will be negative. Now in order to find the electric flux through this curved surface, we will first of all find the solid angle subtended at this point P due to this flat surface ABCD. So in order to find the solid angle, first of all let us find the plane angle theta, which is subtended at this point P. So the plane angle theta will be here equal to 45 degree, because the radius of this imaginary hemispherical surface is r. So this the radius of this flat surface will also be equal to r. So this tan theta will be equal to r upon r, or we can say that theta will be equal to 45 degree. So this angle will be equal to 45 degree, and this angle will also be equal to 45 degree. Now we know that the solid angle which is subtended at this point P by this flat surface ABCD, solid angle at you can say the solid angle subtended at the point P by the flat surface ABCD, this will be equal to 2 pi 1 minus cos theta. So this is the formula for calculating the solid angle, and so by using this formula I will be getting 2 pi 1 minus 1 upon root 2, because theta is equal to 45 degrees, so cos 45 will be equal to 1 by root 2. So the solid angle which is subtended at this point P, where this charge Q is placed by the flat surface ABCD, will be equal to 2 pi 1 minus 2 pi in bracket 1 minus 1 upon root 2. Now let us construct one imaginary sphere. With this flat surface ABCD. Now the solid angle of a sphere is equal to 4 pi. So we can now the flux due to this charge Q which is just placed outside this imaginary hemispherical surface is equal to Q upon epsilon naught. So what we can say, that the flux, that is the electric flux, that is phi is equal to Q upon epsilon naught linked with with the electric flux linked with the solid angle, that is 4 pi, will be equal to Q upon epsilon naught. The electric flux linked with the solid angle 4 pi will be equal to 4 pi, because the flux which is produced by this charge Q, it will be passing through this curved surface, and it will be passing through this entire imaginary sphere also. So the total flux given by Q upon epsilon naught, it will be linked to the solid angle equal to 4 pi. Now so we can say that the electric flux passing through the curved surface APC, this will be equal to what? See, the total this electric flux which is linked with the solid angle 4 pi, which is equal to Q upon epsilon naught. So the electric flux which is linked with the curved surface APC, or you can say the electric flux which is passing through the curved surface APC, this will be equal to Q upon epsilon naught into 2 pi upon 4 pi 1 minus 1 upon root 2. Okay, and this value will be negative, because the flux which is passing through this curved surface is directed inwards, that is, it is directed into the surface. So the flux which is directed into the surface is taken as negative. So the flux which is linked to through this curved surface APC will be equal to minus Q upon epsilon naught into 2 pi upon 4 pi multiplied by 1 minus 1 by root 2, because the 4 pi solid angle is linked to a flux of Q upon epsilon naught. I will just try to tell you how this equation has been you can say how this value has been calculated. So see, 4 pi solid angle is linked to a flux of Q upon epsilon naught. So we can say 1 pi solid angle is equal to Q divided by 4 pi epsilon naught, or we can say now the solid angle which was subtended at this point P by this flat surface was equal to 2 pi in bracket 1 minus 1 upon root 2. So the flux linked with this solid angle, that is 2 pi in bracket 1 minus 1 upon root 2, this will be equal to Q upon 4 pi epsilon naught into 2 pi in bracket 1 minus 1 upon root 2, and this will be negative because the flux is passing through this curved surface and it is directed into the surface. So because it is directed into the surface, this flux will be taken as negative. So the value from here, you can see that this is equal to, this will get cancelled out, and I will be getting the answer as, I will be writing this answer here. This value can be written here as, this one as minus Q upon epsilon naught into, or you can say this can be written as minus 1 by 2 Q upon epsilon naught in bracket 1 minus 1 upon root 2. So this is the electric flux which is linked with the curved surface ABC, and this value is negative because the flux is directed into the surface. Now the total flux which is passing the curved surface and the flat surface, this will be 0, because the flux which is passing to this curved surface will also be passing to this flat surface, but this flux will be passing away from the curved surface. That is, it will be leaving the curved surface. So when it is leaving the curved surface, then this same flux which was negative for this curved surface APC will be positive for the flat surface ABCD, because it is leaving the surface. So the sum of these two will be equal to 0. So the total flux which is passing to the curved surface and the flat surface will be equal to 0, and the total flux which will be passing to the curved surface will be equal to this value, that is minus 1 by 2 into Q upon epsilon naught multiplied by 1 minus 1 upon root 2. So thank you very much for joining this session. In the next session, I will be taking up a different topic from the same chapter of electric charges and field. So till then, have a nice day. Bye.